Hello and welcome to another exciting Breakfast with Unity. I'm your host, Max Moreau, and with me is no one because it's Breakfast with Unity, and I was saying those words just on autopilot. Alright, so what we're going to be doing today is we're going to be making a click to move system. I didn't even create the folder yet, that's exciting. So I'm just going to create a new scene, and we're going to save this scene, and we're going to call this click to move. Click to move. This is going to be like Diablo style movement where you have like a third person character and you click where you want the character to end up. So we're going to create a new folder. We're going to call it 53 click to move. And we're going to throw our click to move Unity level in here. So let's get this set up first. So we're going to create a 3D object. What should be our player? Let's not worry. Let's do a plane first. We're going to need one of those. So this is going to be our plane where the ground is. And we're going to create a light. And we're going to... Do I have any textures that we can use here? We probably have something that's not terrible. Green grass texture is perfect. We could just grab one of these. Throw that in here. Whoops. Throw that in here. There we go. And what are we doing? So we're going to go in here and let's get an angle on this terrain. I'm going to go ahead and do a kind of a corner angle on it. And one of the little tricks you can do here is if you have a camera position that you kind of like in the scene view, you can actually apply it to a camera. If you click the camera, you can go game object. No, yeah, there it is. Game object align with view. Bam. Now the game has a similar view. It's a little bit different because the different cameras have different field of views. As a matter of fact, it probably looks very similar if I put the zoom at a certain point. But yeah, so there we go. And now we can kind of adjust things from there. Another useful thing, if you have it on local coordinates, you can then move along the axes of the object. So that's really useful. So if we want to bring the camera in, we could just kind of do that. And I'm going to angle it down a little bit more now that we've got kind of the basics of where we want this thing, 45 and 0. And what we're going to do is I'm going to shore up these values just a little. And I'm going to raise the camera a bit more and then rotate it down a bit more. There we go. And let's go ahead and make the ground a little bit bigger. Let's make it 1.5 and 1.5. So let's create a character. I'm just going to go with... it'd be nice if we had something that had directionality, and there really is nothing. The cube is probably going to show rotation best, so I'm going to go with the cube. And I want to just make sure that this plane is set to 0, 0, 0, which may mean we may have to adjust the camera up a little bit more. Let's go 6. And let's create a... so we've got the cube. Move this to 0, 0, 0. And I'm going to go ahead and, since this is a character, we're going to create an empty child and then make it into the parent. And the reason I do it this way is just that's an easy way to guarantee that the cube will be in the same position as the parent. We're all at 0, 0, so it's really easy right now, but just in case you weren't. So we're going to call this player. And the reason we're doing this is so that we can actually offset the character model. So, as I said, it's pretty standard in games to have the pivot point for a character be the bottom of the object. So that's what we're setting up here. What did I do wrong? Center. There it is. So if we switch it to pivot view, you can see that the pivot is now at the base of the character. You can see that it's right at the bottom there. And this will be useful because the positions we're going to be getting are going to be based on the ground plane. And so this will allow us to work with this. So what we're going to do is let's start on this script. Click to move. Create C# script. And we're going to call this click to move. Or actually, let's just make it move to click location. And we're going to be using our old friend raycasts to do this. So, all right. So, what are we doing? Public, float, movement, speed, public, layer mask, movement, layer. And we'll set these to meaningful initial values. So we'll do -1, so that's everything. So it'll work in some way. And movement speed 1.0 is usually what I do for the default movement speed, 1.0F. So I think that's all we're going to need here. Oh, yeah, maybe rotation speed. Let's do a public float rotation speed equals 30.0F. I usually think 30 degrees a second is a good starting rotation speed. It's usually a little too slow. I just want it to show that it's working, though, you know? If someone just drags the script in, I want it to work in a general way. So, start. We don't need a start. We just need an update. So, when we click, so if input.get mouse button down, so if we've clicked, oh, and we have to specify the button, so 0. That means button, the left mouse button. 1 is the right mouse button, and then all the other numbers are whatever else you have on the mouse. So, input.get mouse button down. So if we've clicked, so we're going to check to see if we clicked on something. So the way we're going to do that is by casting array. So we're going to need a raycast hit, because we're going to want the hit information. So if physics.raycast, and actually this is a very special, actually we'll just start with the raycast and I'll show you what the problem is. Actually no, it may not be a problem. Physics.raycast, yeah, it's not a problem. I was thinking about it wrong. We need array and or an origin and a direction, and we need a layer mask, and we need a hit info. So it'll look something like, we need layer mask and hit info. There we go. So it'll look something like this: ray, hit info, distance, layer mask, or this origin direction. We usually do the origin direction. In this case, we're going to do ray because cameras have a very useful function in them to get a ray for you. So we're going to do camera.main.screen point to ray. Actually, we want viewport point. No, we don't want any of these. We want viewport point to ray. That's what we want. So viewport point to array, what this means is it's in viewport space. Viewport space is normalized, which means it goes from 0 to 1 and 0 to 1. So that makes it really useful to find the center of it. So we want this, oh wait, we actually don't want the center. Sorry, hold on. Screen point to array is what we want, because we want to know where we clicked, not where the center of the screen is. So screen point to array, and we need the position here. We can feed in our input.mouse position. Screen point array does it in screen space, which is in pixel space, so it has it by the number of pixels. And input.mouse position returns the position in pixels, so this will give us exactly what we want. So that's our array. We go all the way back down here to hit info, distance, layer mask. So we do out hit, because it's an output thing. And we do distance, which we don't care about, so math f.infinity for now. You could also set a distance as an option. And then layer mask, we're just going to pass in our movement layer, which was up here declared. The -1 here, by the way, sets this so that it collides with everything by default. It's a convenience thing. So movement layer, that should be the raycast. So this means we've sent out array where we clicked when we click. So now, so this means that we also hit something, and the layer mask is in here. So if we've set things to not hit there, if it doesn't hit anything, nothing's going to happen. That's fine. But if it does hit something, we want to start moving the player there. So we're going to need some extra stuff for this. We're going to need a private vector3 target position and private quaternion target rotation. So we're going to set both of these when we click somewhere. So target position is easy. Target position equals hit dot point. There, we're done. Rotation, target rotation is a little bit trickier, not that much though. Target rotation equals target rotation equals, yeah, this is a lot trickier. So move to click location. This is going to be on the object that's moving. So we will do transform dot position minus target position, and that should give us a vector going towards that, and we need to turn this into quaternion. So quaternion dot look rotation. This means we want the object to look at that vector. I might have these terms reversed. We can always fix that in a moment if that doesn't work. So this still isn't going to show anything though, because this is just setting the target position and target rotation. So we need to actually do something with these target stuff. So what we'll do after here is yeah, we'll start a coroutine for this. So we'll also stop all coroutines. So stop all coroutines and start coroutine, and the coroutine will be called, what are we going to call it? We're going to call it move and rotate. Actually, we'll just do, should we do 2 coroutines? Why not? Yeah. So move routine is what we're going to call it. And we'll duplicate this again and rotate routine. Save. So void, actually, sorry, I enumerator. I haven't done the coroutine in a while. Wow, it's kind of weird. We're doing move routine. And what we're going to do is we need a float t equals 0.0f. Oh wait, no, this is, actually this will be easier to not do a separate routine. We'll just do the rotate routine. We'll start with that. So the rotate routine will be, we don't need that either. I'm going back on what I said, we're not doing coroutines today. So the movement will be transform so I'll move to the target position. We don't want to pass the target position. And we can't set the target position to null. We're going to need another variable. Private bool at target equals false. Actually equals true. So we'll set at target equals false. My brain's not on this morning, but that's okay. It's the morning. So at target equals false. So that means if not at target, we move forward. We do a check here. So we're going to transform. Actually, we're going to say vector 3 new position equals transform dot position. New position plus equals transform dot forward times movement speed times time dot delta time. So this will be the move. Now the reason I've set it up as a temporary variable rather than just putting this directly into the transform dot position is we need to check to see if this new position is past our goal. So the way we do that is if and actually we're going to use this term again. So we're going to say vector 3 direction. I'm going to call it move direction. Move direction equals, and we'll do this. Now we can use move direction here. And the reason I want to do that is now we don't have to recalculate this twice when we check it. So we're going to say if the dot product mathf vector 3 dot, there we go. It's vector math, so it should be in vectors. So we're going to dot the move direction with new position minus so wait, we've got move direction, yeah, minus I'm assuming this is right. We might have to flip it, as I said, I always get this wrong. Minus target position. So that's what it's called, right? Yeah, it is. It just isn't helping me today. Is greater than, or is less than 0.0f. Less than or equal to is what we'll go with. So what this means is we're doing a dot product, and the dot product, if you have two vectors that are pointed in exactly the same direction, they will return 1. If they're pointed in exactly opposite directions, they will return -1. And what's really useful is at 0, they're perpendicular. So anything lower than 0 means behind us. So if our move direction dotted with the direction to the target location are pointing in the same direction, that means we haven't reached it. If they aren't, that means that we've passed it. And so if it's less than or equal to -0.0f, what did I miss here? Hold on. It says there's an error there. 1, 2, 3, 4. Oh, don't need that extra one. So this means that we're done moving. So we can say at this point at target equals true. And if we're not at that point, else, we want to move towards it. So we will do, and actually we will set the player position here too. Transform.position equals target position. And in the else statement, what we're going to do is transform.position equals new position. And part of the reason that autocomplete is hating me is because that semicolon is missing. So there we go. This should do the movement. We'll worry about the rotation in just a moment here. So let's see if the movement actually works. Let's see if we can get this thing to work. So we're going to go to the player queue, or the player rather, and we're going to move to click location on net, and we're going to just leave the movement layer on everything so I can demonstrate some stuff. So if we do this and hit play, and we click, all right, you can see that my code is the opposite of what we wanted. So what we want to do is we want to change this to be exactly the opposite. As I said, sometimes I get this wrong. Save. So if I do that and hit play, and we click on a position. Okay, no, I've got something else wrong. Oh yeah, we've got some serious errors. Okay, so that was not the problem. Uh-oh. Uh-oh. Gonna be a longer episode this morning. So save. So target position equals hit dot point. Target rotation, look rotation. Let's just quickly debug that debug.draw line. Let's go ahead and draw a line based on this for right now. So we're just going to draw a line between target position and transfer dot position and target position just to see how this is going. So we're going to hit play and click, and it totally didn't draw my line. Did I not save? I did. Maybe it drew my line and we couldn't see it because of the plane. I'm going to just temporarily make the plane invisible. We're going to turn off the mesh renderer, and we're going to hit play, and I'm going to click and see what we get. Okay, I don't see a line anywhere. Something else I have to do to make it stay longer. Color duration. So color dot white duration 1.0f. Save. Curious. Very curious. Alright, what did I do wrong? So, camera. Target position equals hit dot point, target rotation, look rotation. New position equals transform dot position, move directions, transform dot forward times movement speed times time dot delta time. New position. Oh, wait. Duh, we need the rotation here because I'm not actually using, I'm not directly moving them to the target. That makes sense. So we need the rotation. Alright, so if not a target, and then the other thing we're going to do is we're going to rotate towards our quaternion. So that's an easier line, actually, believe it or not. Believe it or not, the quaternion lines are going to be easier. So we're going to do transform, as a matter of fact, I think it's just one line, without rotation, equals quaternion dot look rotation, quaternion dot angle from to rotation, look rotation, rotate towards. That's the one we want. Rotate towards. So we need a from and a to. So this is going to be our from rotation is going to be our current rotation. So transform dot rotation, and our to rotation is going to be quaternion dot look rotation, and I'm going to use this math again. Although since we're doing it again, since I used the term again, maybe we should cut. I'm just going to put it in here right now, just make sure it works. So quaternion dot look rotation, new position minus target position. And finally, we do max series delta. We're going to do whatever we set here, rotation speed times time dot delta time. Save. All right, now maybe it'll work if we didn't have a problem. Oh, new position is okay. So we do need this. So I'm just gonna go ahead and put this up here. And now we can use it down there as well. So we can just hit save. There we go. And I'm going to go ahead and make that plane visible again. So turn that on. And then we're going to hit play. And hopefully, maybe... Okay, so we do have it backwards. But now it's actually kind of doing what we want. So, as I said, might have to reverse these. And so we do that, and we probably need to do that here as well. Actually, I might only need to do that here. Whoops, that's not what I wanted. We have different terms here. Again, apologies for the long episode. Save. I actually thought this was going to go a little bit shorter, but then I always forget how many little details there are in this type of thing. So we have it rotating. It's going. Oh, okay. So okay, made a mistake in our implementation here. So the problem here is that would assume that we've already started facing our location before we started moving. The reason is because we were actually, no, maybe. So yeah, if we go. Okay, so my dot product is definitely wrong. May not be the only thing wrong, though. I think we've got an assumption that will be a problem. I think it's going to... So I think this will work if we click in front of where the player's facing, but he'll probably directly teleport in the case where we don't click in front. Yeah, that's what I was worried about. The reason being is if we click behind, he immediately starts trying to move to his location, and he's already facing away from it, and we do that dot product to determine if we've gotten to the location, and that assumption only works if we're moving the object and it's already looking towards the location. So we can fix that by just doing one more boolean. Let's just do it. Private bool facing target equals false. And so if not at target, what we're going to do is we do the dot, and in this case is if facing target, then we do this. So if facing target, we do this. Else, all we do is so we don't want to actually, so we want this else to happen only if, okay, yeah, here we go. Put it in the wrong place. So we want this here. So if facing target transfer to position equals new position. So what this means is we failed and we were facing the target. Now if so we need to actually set facing target now in a scenario here. So so in this else statement, no, this means that wait. Sorry, this is where I wanted it. All right. So if we're not facing the target, and we were facing the target originally, we set our final positions. So if we are facing the target, so if the else statement, this means that we are facing target. We aren't facing target. If we are facing the target, then we set facing target equals true. So now when do we reset facing target? Probably the safest place we'll do that is in here. Facing target equals false. Let's see if this works. Play. Please work. Alright, the cube rotates and doesn't move anymore at all. Why is it not moving anymore? Oh. Wait, what did I do? What did I delete here? Jeez, what am I doing? Okay, hold on. Undo, 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 undo. Why did I get rid of the things that were there? Yeah, that's kind of an important line. All right, so I'm just going to, I did a safety copy there, and then we're just going to copy this back in, and we're gonna do all of this stuff. All of this stuff. And move all this stuff over. And I'm sure we're going to have compile errors now after that type of thing. Oh, maybe not. Maybe I got lucky. Is this going to work now? Oh, you're still not. Oh, okay. So he's only moving forward after he rotates towards it. Yeah, that's kind of cool. So let's just make that rotation a lot faster. So we're going to do rotation speed 60 and movement speed. Let's make it 3. We need more faster, about 120. Most Diablo games actually just rotate you immediately, so you could also do that. Uh-oh, we've got a special case at 0. So if we go someplace where it turns... Okay, so if we go directly behind it... No. Okay, the reason for that is if we make an immediate new move while we're already moving. Yeah. Alright, we're going to make this a two-parter. Gonna clean this up on the next episode. So you can see how easy it is, yay! But yeah, no, I mean it's just getting the right recipe together to make this work, right? So, but yeah, it'll be a useful script once we're done with it. So anyway, thank you for watching this morning. Thank you for being patient with me. Sorry I've been missing episodes yesterday, so hopefully we won't have as much bumpiness as the new year progresses. So thank you very much for joining. If you have any questions, please email me pushypixels@pushypixels.com. You can also tweet me at Drakfire. That's DRAKFYRE. And yeah. Donate to pushing with Unity. Donate to Cooking with Unity. Patreon.com/Cooking with Unity. Really appreciate your support. Thank you very much, and you guys have a great one. I'll catch you tomorrow, and we'll finish this thing off.